an electric water heater has to supply hot water at 40 degrees Celsius at a constant rate 1 kilogram per second from water at 30 degrees Celsius. If the heat loss to surrounding is neglected, the minimum power of the heating element of the heater should be specific heat capacity of water is 4200. Then we can get heat energy absorption rate of water, ms theta divided by time. It should be the minimum power because of there is no heat loss to the environment. Mass 1 kilogram per second. Specific heat capacity 4200. Temperature increasement for 30 to 40, it means 10 degrees. Time 1 second. We can get 4.2 into 10 to the power 4. Then first one is correct answer. A mass Mi of ice at 0 degrees is added to a mass Mw of water at room temperature of 30 degrees and the mixture is stirred until the ice is completely dissolved in water. If the minimum temperature of the mixture is found to be 10 degrees, the amount of heat absorbed by the mixture from the container and environment is. They have given specific heat capacity of water SW, latent heat of fusion ice L. We can consider heat absorption of ice. Heat absorption of ice should be equal to heat emitted by water plus environment. It is the relationship. There are two methods to heat absorption by ice. It is Mi L to melt. After melting, its temperature should be increased up to 10 degrees, 0 to 10. 10 is the minimum temperature we have found. Then Mi SW, specific heat of water, 0 to 10 degrees means there is a temperature change 10 degrees. Heat emitted by water, mass of water Mw, SW, initial temperature of water is 30 degrees, it should be cooled to 10 degrees, then temperature difference 20, plus temperature given by environment, I will consider it as X. Then we have subject X. We can get Mi as a common factor for this side, L plus 10 SW, and we have to subtract this term, minus 20 SW Mw. Then we can obtain, second one is the correct answer. A metal block X of mass M at temperature theta degree, 0 degree, is made to contact with another metal block Y of mass 2m at temperature 100 degrees. Heat transfer takes place when X and Y with no heat loss to the surroundings. The specific heat capacity of X and Y metals are Cx and Cy respectively. The final equilibrium temperature of the metal block is 20 Celsius. Then we have to get the relationship between Cx and Cy. We can obtain heat loss of Y should be equal to heat gain of X. We can obtain ms theta. Mass of X, M, specific heat capacity Cx, temperature difference 0 to 20, it is 20. mass of Y2M, specific heat capacity Cy, temperature 100 to 20, it is 80. Then we can cancel out m term, divide by 2, then we can get 8 Cy equals Cx. First one is the correct answer. Crushed ice is at 0 degrees Celsius are kept inside thermally insulated closed container. Heat is supplied to the container at a constant rate and the pressure inside the container is kept constant. The variation of temperature inside the container with time is best represented by heat absorbed by material to the fusion is a small value like this. The heat absorbed amount of heat energy is directly proportional to absorbed time because of there is a constant rate of heat. Then increasing temperature, and after at 100 degrees Celsius we can observe that there is another phase change, it is boiling. The time taken to boiling is greater than time taken to melting. After that, gradient of the graph should be less than previous one because of it is difficult to increase the temperature of water. It is like this. Then we can obtain. Second one should be the correct answer. Figure shows the cooling curve of liquid wax of mass M, specific heat capacity HL, and latent heat of fusion L. The heat capacity of the container can be neglected. Consider the following statement. They have given cooling curve. It is like this. First statement, statement A, gradient of curve A dash at A, it means gradient of this part, tan value of this angle, is equal to gradient of curve BB dash at B. Now we know that cooling gradient of cooling curve is representing cooling rate. Cooling rate is depending on the state of matter. This one is solid, this one is liquid. Therefore, it is false. A is false. In statement B, the rate of heat released surrounding during the time T, ml over T. Yes, we can get heat loss is ml divided by this time period is given as T. Then it is heat loss rate. B is correct. Statement C, gradient of curve A dash at A is 1 over SL times L over T. We can get the cooling rate at this situation is theta over T. Then we can write ms theta over T equals ml over T because of there is a constant temperature for this situation, this region. This heat loss rate is depending on excess temperature with the room, according to the Newton's law. Then we can cancel out m and m. Gradient is this value. Theta over T is 1 over S times L over T. Then it is correct. Statement C is correct. B and C only true. Then third one is the correct answer. The figure shows the amount of heat Q in kilojoule absorbed by 1 kilogram of ice under each of the states when it is heated from temperature 50 to 100 degrees. Which of the following statement is incorrect? First one, specific latent heat of fusion of ice is 333 into 10 to the power 3 joules per kilogram. Yes, it is correct. We can observe that temperature is increasing from -50 to 0. After that, This part is fusion. They have given it is 333 kilojoules. 333 kilojoules. It means 333 into 10 to the power 3 joules. They have considered only 1 kilogram. Therefore, it is per kilogram. In second one, specific latent heat of vaporization is 2256 into 10 to the power 3. Yes, it is also correct. It is related to this part of the graph. Same thing. They have given 2256, axis is in kilojoules. 2 also correct. Then 3, specific heat capacity of ice is 1110 joules per kilogram. No, it is false. For this part, we can get ms theta is 111 kilojoules, 10 to the power 3. Mass 1 kilogram, we have to find S value. Temperature difference is 50. Then S value is not given value. Therefore, statement C is the incorrect statement. We have to find an incorrect statement, then it is C. A vessel of negligible heat capacity contains water of mass m0 at the room temperature 30 degrees. When the mass m1 of water at 100 degrees is added to the vessel, the maximum of mixture becomes T times. Neglect heat losses. The variation of T time with m1 of m0 is best represented by. We know that when increasing m1 value, final temperature should be increasing, but it should be less than 100 degrees, always less than 100 degrees. Therefore, it is increasing up to around 90 degrees. Second one is the correct graph. Minimum amount of heat that is necessary to melt completely an ice cube of mass 30 grams at 0 degrees C. They have given specific latent heat of fusion of ice 3.3 into 10 to the power 5. Then we have to get minimum heat energy should be ml. Mass 30 grams, we have to convert it to kilograms divided by 1000. Latent heat 3.3 into 10 to the power 5. Then we have to simplify it. 10 to the power 2, 3. 3 zeros, 3 into 3, 9, 3 into 3, 9. We have to separate one decimal place. It is 9900 joules. Then answer is 4. SI unit of quantity of heat is. We know that heat is an energy. Then SI unit is joules. Answer is 4. An electric kettle requires 0.2 kilowatt hours to rise the temperature of 2 kilogram of water from 28 to boiling point 100 degrees. If the specific heat capacity of water is 4200, the efficiency of the kettle. Efficiency means output ms theta divided by given energy. Given energy is 0.2 kilowatt hours. 0.2 kilowatt hours means 0.2 multiplied by 1000 hours. Joules per hour. It is per hour. It is hours. Kilowatt. We have to convert to watt by multiplying by 1000. Then we have to convert it to seconds. 3600. The heat energy absorbed by water is ms theta. We have to substitute given energy in kilowatt hours. Kilowatt hours. Kilowatt means 0.2 times 1000 watt. Hours, it is power into time. Work done is power into time. We have to substitute hour by second. This 3600. When getting efficiency, it is a percentage we have to multiply by 100%. Then mass is 2 kilograms. Specific heat capacity of ice 4,002, water 4,200. Temperature increasement 28 to 100, it is 72. Multiply by 100, divide by this value 0.2 into 1000 into 3600. We can cancel out 2 zeros. 36 divided by 36, 1, 2. 2 zeros, 0.2 into 10, 2. We can cancel out this 2. 42 into 2, 84%. It is the efficiency of considered heating element. Then we can obtain fifth one is the correct answer.